to factor binomials, trinomials, and polynomials, and to find and use greatest common factors among constants, variables, and expressions. For example, let's say you had two numbers, 4 and 10. There's a 4 and there's a 10, and they're added together. Clearly the answer is 14, but that's not what we're interested in. First, we want to find the highest number that comes out of both of them. What's the highest number you can divide into both numbers? 2. So what I would do from there is put 2 outside of a set of parentheses and then divide everything inside by 2. So I would end up with 4 over 2, which is 2, and then 10 over 2, which is 5. Now I've factored out a 2. That's what we've just done. We factored out a 2 from the 4 and 10. Take note that 2 plus 5 is 7, times 2 is 14. So the answer is still the same. But what we're practicing here is factoring out. You're going to do this with variables and not just numbers. One way you can look at this problem is the following. Here's 4. The factors of 4 are 1, 2, and 4. The factors of 10 are 1, 2, 5, and 10. What's the highest number they both have in common? 2. So that's how we determine the number that we're going to take out of those two. On this one, let's say we had 12 and 8, and we want to factor out from those. The factors of 12 are 1, 2, 3, 4, 6, and 12. The factors of 8 are 1, 2, 4, and 8. What's the highest number they have in common? 4. So I would put 4 out here, and then on the inside divide 12 by 4, and then 8 by 4. And then simplify. 12 over 4 is 3, and 8 over 4 is 2. So I've factored out a 4, so it's really 4 times the quantity 3 plus 2. It'll still give you 20 from the beginning up here. Now these are two basic problems that you won't even have to do because they're not the first example yet. Here's your real first example. Let's say we have a to the third plus a to the second. Of all the things that you can divide out a to the third by, and it comes out with something that's, even, then you should list those. A to the third, you can divide a to the third by a squared, and a to the third. We had a test over stuff like this before where you divided a to the third by a to the second, and you subtract the exponents, and you're left with a. That's something you have to remember for this, but for right now, here are the factors of a to the third. And then a to the second, you can divide that by a and a to the second. Now, what's the highest thing they both have in common? A to the second. So you would come up here and put a to the second and divide each term by a to the second. And once you do that, you go back and simplify. A to the third over a to the second. 3 minus 2 is 1. A to the first, you don't write 1 in the exponent. It's just a. And I have a squared divided by a squared. Something divided by itself is always what? 1. So you would have a squared times the quantity a plus 1. That's the factorization. That's the most you can take out of a to the third plus a squared. In this problem, we have b to the sixth plus b to the fourth. For b to the sixth, the factors would be b squared, b to the third, b to the fourth, b to the fifth, and b to the sixth. For b to the fourth, you could divide out a b squared, b to the third, and b to the fourth. What's the highest they have in common? B to the fourth. And once you recognize the pattern, you don't have to write all that out each time. So here's b to the fourth, and then we go back and divide each of these two by b to the fourth. And when you do that, simplify on the inside. B to the sixth over b to the fourth is what? B to the second, and then this over itself. 1. So this is your answer. B to the fourth times the quantity b squared plus 1. In this problem, it is b to the seventh plus b to the fifth. On the practice problem, you can factor out b to the fifth and then do b to the seventh over b to the fifth plus b to the fifth over b to the fifth. And you'll be left with b to the fifth times the quantity of b squared plus 1. For example, if I had 12x to the sixth minus 8x to the third. Whenever you have coefficients next to your variable, coefficients are 12 and 8. Do the numbers first. Find the highest number that comes out of 12 and 8. What's the highest number that goes into both?
4.
4. So put 4 down out to the left. Once you've done that, then go back and mess with the variables. What am I going to factor out from the variables? X to the third, because x to the third is the lowest power of x in the whole problem. Can't take out a 6. X to the sixth because it's larger than this. The lowest power of x is x to the third. So that's what we write down here. And then from there you go back and divide. Divide everything by 4x to the third. And inside you would simplify. 12 over 4 is what?
3x to the third.
3, and then it would be x to the third because of 6 minus 3. And then 8 over 4,
2.
and then what?
X.
These just cancel out to 1, so there's no need to write it. So you're just left with 2. So the answer to the whole problem is here. In this practice problem, we have 16a to the third plus 12a. Factor that out completely. The solution for the practice problem, the highest number you can take out from 16 and 12 is what?
4.
4. And what's the lowest power of a in this?
1.
Yeah, just 1 to the first power, so it would be a. And you'll divide 16a to the third by 4a and 12a by 4a. 16 over 4 is 4, and a to the third over a is a squared. 12 over 4 is 3, and the a's cancel completely out. There's nothing to write. So this is it.
Oh, God.
My God, it's still